For f of x equals x to the third minus 2x plus 3, find g of x equals negative f of 1/2 x. Describe the transformations. Okay, so looking at g of x and f of x, notice that your f of 1/2 x, your 1/2 is inside. So that means you're going to have a horizontal stretch by 2. And also you have a negative sign outside the f of x. That means you're going to be doing a vertical reflection or an x-axis reflection. Okay, so let me just write g of x. So let's write g of x. It's going to be equal to, and I'll put the negative sign out in front here. And that applies to all of f of x, so I'm going to use these big old brackets. Then 1/2 x is going to be used for each of these x's. So you're going to have 1/2 x to the third minus 2 times 1/2 x plus 3. And the 3 doesn't change because there's no x in that term. So all I did is I inputted this 1/2 x into each of the x's in the f of x function, and that makes the g of x. And then the negative sign, of course, out in front. Okay, so let's take a look at the transformations once again. We have the 1/2 x, which is a horizontal stretch by 2, and then we have the negative sign out in front of the f, which means we're doing a vertical reflection. Okay, so I'm going to simplify this function further. And 1/2 x all to the third power, that's the same thing as 1/2 to the third power and then x to the third power. So I'm just going to split that up, 1/2 to the third and then x to the third. And the next term is minus 2 times 1/2 x. Well, 2 times 1/2 is 1, so it's just going to be 1x or x. And then the plus 3 doesn't change. Okay, so g of x equals negative of 1/2 to the third is 1/8. So it's 1/8 x to the third and then minus x plus 3 all inside these brackets. Now I just need to distribute the negative 1 or the negative invisible 1. So it's going to be negative 1/8 x to the third. And then negative 1 times negative x is positive, so plus x. Negative 1 times positive 3 is negative 3, so minus 3. Okay, here's your g of x. Right there. And we said the transformations, there was going to be a horizontal stretch by 2. And then an x-axis reflection. Okay, let's get to the calculator and see if we can verify this. So there, clear out the old functions. I'm going to have x to the third minus 2x plus 3. And then we have negative of 1 divided by 8, and I'm putting that in parentheses, negative 1 divided by 8, and then x to the third power and then we have plus x and then plus 3, or minus 3 rather. So you have negative 1/8 x to the third plus x minus 3. So let's graph these. There's f of x. and there's g of x. Okay, there's definitely that reflection going on through the x-axis. There's a vertical reflection here that you can see. And also, there's a horizontal stretch here. Notice how this function seems wider. Let's take a look at the table here. Okay, now here's how you figure out a horizontal stretch or shrink by looking at the table. You have to focus on the inputs. Notice, for example, I'll select the input of 2. And notice how the output for f of x is 7. A horizontal stretch of 2 means an input of 4 will give you 7 on the g of x. So if you look at 4, you get 7. But it's actually negative because of that vertical reflection as well. See how it goes 2, 7 for the f of x, and then 4, 7 for the g of x. Let's look at another one. 3 is 24 for f of x, and that means 6 should be 24, or negative 24 with a reflection for g of x. Okay, let's look at the negatives. You have negative 2, output of 1. We actually have to go up here on the table. And negative 4, output of 1 for g of x. Okay, so that's how, looking at a table, you can see a horizontal stretch, because it takes double the input to make that same output. And that's what makes the function twice as wide, the g of x. Okay, so here's our function once again, and it is a horizontal stretch by 2 and an x-axis reflection.